Okay, how do we find the antiderivative of the absolute value of x? First of all, what is absolute value of x? Absolute value of x is x if x is bigger than or equal to 0, negative x if x is less than or equal to 0. And so this is the piecewise function. And so to find the antiderivative, the first step, let's say this is capital P of x. Take the antiderivative of this one, and that would be x to the power 1 more divided by 2. Take the antiderivative of this one, negative x to the power 1, then 2 to the power divided by 2. And plus c, this is the general form. And so one thing is that you may want to assume that p of x, the capital P of x, is continuous. Otherwise, this two c's can be different values. And so assuming that underscore P of x is the derivative of capital P of x, we can say the capital P of x is continuous. And so that would be the antiderivative. Okay, now let's do example 3, and this is an example of how we model using antiderivatives. So a particle is moving along the x-axis. In each case, find the position function s of t of the particle. Let's say the velocity function is v of t equal to t to the power t feet per second, and s of 2 equal to 9. Oh, this is a little better than what we did in the beginning when we posed the questions with the guava. Now I have basically some value for s, and I want to find the entire function s. So I have basically, we call this initial value. And so again, s of t, derivative of s of t is the velocity. The derivative of position is velocity. So s of t is antiderivative of velocity. One way goes, this one is derivative of that one, so the other one is the antiderivative of this one, basically. So taking the antiderivative, let's remember when we were taking the antiderivative, it's going to be undoing the derivative. So because it's an exponential function, it was the exponential functions and divided by natural log of 3. And so by natural log of the base, and plus c. And c is the constant that I don't know. So what I did here is I found the general antiderivative of the velocity function. But I know a little better because there's an exact value at 2, and that should determine c. So if I plug in for t, I plug in 2, and for s, I plug in 9. See here, for t, you plug in the input, which is 2, and then in here, in here goes a 2. Then output should be 9. So that's what we do next. We plug in 9 for s and 2 for t, and then it turns out now we get 9 is equal to 3 to the power 2 natural log of 3 plus c, and then you solve for c, and then you have to put it back in the function again. So basically at the end, s of t ends up with being s of t is going to be 3 to the power t over natural log of 3 plus 9 minus 9 over natural log of 3. And so that was the option 1. when the velocity function was an exponential. What if the acceleration function is equal to 2t plus 5 and initial velocity is negative 5 feet per second and s of t is equal to 2. So in this case, let's remember, the derivative of the position is velocity, derivative of velocity is acceleration. Now let's go back. If I do antiderivative of acceleration, I get a velocity and I have an initial velocity for that. If I antiderivative the velocity that I found, then I should find the position vector and I have an initial value for that I can use as well. So let's do all of that. So velocity, if I take the antiderivative of 2t plus 5, let's see, antiderivative 2t plus 5 dt, we know that we have to take the antiderivative term by term, and so 2 antiderivative of t dt plus 5 antiderivative of, sometimes we write it like that, and so 2t to the power 2 divided by 2 plus 5t plus c, and that's the antiderivative. And then I have to take another antiderivative of that to find s of t. So how does that work? Antiderivative of t squared is t to the power 3 divided by 3. It's t to power 1 more divided by the new power. And here 5t to power, the antiderivative of 5t becomes 5t to power 1 more divided by 2. Same thing for c. C is the constant coefficient. It becomes ct plus another constant that was lost during the derivation. It has to come back. And now I have to decide how to choose this initial values. Again, when I was taking this antiderivative, I didn't show the work that was like this. This is that antiderivative. Now let's use the initial values. The initial value for velocity should go in here, and that will help me solve c. Then I put c back in here and use this initial value to solve for d. So if I plug in the values for v, initial velocity v at 0 equal to negative 5, plug in 0 in here, and for input, for output you get 5. So it would be 5 equal to 0 plus c, which is going to give me, oh sorry, the initial velocity is negative 5. Negative 5 equal to, so c is equal to negative 5. Now plug it back into here to get t to the power 3 divided by 3 plus 5 half t squared plus minus 5t plus d. Now this time plug in 1 for t, and then output should be 2, and you compute d in there. So using the computation, you get basically minus 5 plus d, and you compute d, and d turns out to be 25 divided by c. So s of t basically is t to the power 3 divided by 3 plus 5 t to the power 2 divided by 2 minus 5 t plus 25 over 6. So by replacing c and d. I click at question 3. Suppose f double prime of x is equal to cosine of x, and f prime of pi is equal to 8, and f of pi equal to 1. Find f at 0. Now we're back. Let's see. I have to start over here. That's the only place that I have a function. So I do antiderivative of f double prime of x. And remember, f double prime is the derivative of f prime. So this should be f prime of x plus c. And then let's do another antiderivative. First compute. That would be equal to antiderivative of cosine is negative sine. Cosine of x is negative sine. And let's see. Now, let's try to find f of x, and that would be another antiderivative. So we're discussing f double prime, and I want to find f at some value. I know that I'm supposed to undo the derivative until I get to f. So let's start with undoing the derivative once. And then I end up with, what's the antiderivative of cosine of x? Sine of x is a plus c. Now, let's see. I have to use this flow fact to find c, and that is f prime at pi equal to 8. Also, f prime at pi is equal to sine of pi plus c, and that is sine of pi is equal to 0 plus c, so c is equal to 8. And so now I know f prime is equal to sine of x plus 8. Now take another antiderivative to find f of x. Undo the derivative one more time. dx. And that is, and derivative of antiderivative of sine is negative cosine, and plus 8x plus d. Now plug in that initial value, f of pi is equal to negative cosine of pi plus 8 pi plus d, and this is supposed to be equal to 1. So 1 is equal to negative cosine of pi is negative 1, so plus 1 plus 8 pi plus d, so d is equal to 8 pi. This means this was the that was f of x, f of x, which is going to be negative cosine of x plus 8x plus 8 pi. Now plugging in 0, what you end up with is f of 0 equal to minus cosine of 0 plus 0 plus 8 pi. And that is 8 pi minus 1. This one's a minus 1. And so f of 0 here, negative 8 pi, negative, negative. These are all negative signs. Negative 8 pi minus 1.